Hi, Lishardy. Um, I guess I'll be solving this fan truss. It's called fan truss. Have a fan truss. So first you need to draw your truss out like this. And then step 2, you have to check if the truss is statically determinate. And I already did the math. And the equation, the original equation for it is 2j equal m plus r, which means 2 times how many joints there are equal to how many member plus how many reaction force do you have. And then if it's not equal, then it's incorrect. And then step 3, you need to find the external forces, which means you have to use the 3 static equilibrium equations. Well, first I find the sum of moments the fan truss have, and I got that. And then I find the sum of force in the y direction, and I got 105 pounds. And then I find the sum of the forces in the x direction, which is 120. Then step 4, you need to use the inverse SOHCAHTOA to find the angles, all of the angles. And step 5, redraw the truss, showing all the external forces and the angles, so that it's be easier for you to do step 6 and step 7. And then step 7 is find the internal forces of each member of the truss. And first, you have to find which joints you're gonna choose. So, and I chose A because as you say, it's easier to use A and C. And I got that. And it's in compression because it's going clockwise motion, which means compression, and it's negative, so that's why it's in compression. And then for the sum of force in the x direction equals 0, I got 225 in tension because it's positive. And I say this is because it has to be the same for members DE and EF, because of Newton's second law of motion that states that the acceleration of an object is proportional to the net force acting on the object, and inversely proportional to the object's mass, which can simplify as F equal ma, which means force equal mass times acceleration. And then I go and I find joint C because it's the closest and easiest, and that's what I got for the sum of force in the y direction, and it's negative because it's compression. And then I find the sum of forces in the x direction, which I find 0. And then I did the same thing for joint B. And then I got the sum of forces in the y direction is 503.112, or just 12. And it's in tension because it's positive. And this is just 0 because I was using, you would use the same, I mean, if you use a cosine of 63.435 instead, then you would get 0 anyway, so we just put 0. And then step 7 is when you redraw everything, and this is what I got. And if that's too unclear, then I have the bigger version, which is this. My shadow's in the way.